Welcome back learners to our YouTube channel, Roboarmy. Today, we will show you how to make a smart door lock with Arduino. Consider it to be the door of the house. If we have to make a smart and easy door lock for it, what do we have to do? First, we require a servo motor that will control the locking and unlocking of the door. One 4x4 keypad to enter the password. One 16x2 LCD display to show the instructions and feedback to the user. And one Arduino Uno board as our main controller. Let's take a look at some additional components that are required for this project. Some jumper wires. One USB cable. A double battery holder with a DC power jack and switch. 2 lithium-ion cells. This is the connection diagram of our project. Carefully align the I2C module with the LCD pins like this. If you want to know more about 16x2 LCD display and I2C module, click on the info button or link given below in the description. Now take the male to female jumper wires and insert them in the module. Take the Arduino board. First, connect the GND pin of the I2C module to the GND pin of the Arduino. Next, connect the VCC pin to the 5 volts pin of the Arduino. Then, connect the SDA pin to the SDA of the Arduino. Finally, connect the SCL to the SCL pin of the Arduino. Some Arduinos may not have SCL and SDA pins. So make sure if your board doesn't have these pins, you can connect the SDA pin of the module to the A4 pin and SCL to A5 pin of Arduino. By connecting the SDA and SCL pins from our LCD display to our Arduino, we can control what to show and when to show it. Now, we will connect the 4x4 keypad to the Arduino. This keypad has 16 buttons arranged in a matrix of 4 rows and 4 columns. It operates on a matrix system where each button press connects a specific row and column. This allows for easy detection of which key is pressed using fewer input pins. It has 8 pins. 4 pins are connected to the rows, and the other 4 are connected to the columns. Take male-to-male jumper wires and insert them in the keypad. Connect the row pins to Arduino pins 2, 3, 4, and 5. Then, connect the column pins to Arduino pins 6, 7, 8, and 9. Now the servo motor has 3 wires, brown for ground, red for power, and orange for signal. Take the male-to-male jumper wires and insert them like this. Now, connect the brown wire to the ground pin on the Arduino. The red wire to the 5 volts pin. And the orange wire to digital pin 10. Again, verify the connections according to this circuit diagram. Before we move on, let's understand the logic we want to create in this project. The Arduino will initialize the LCD to show enter password, prompting the user to enter the current password. The keypad will accept numeric input from 0 to 9 as password. The Arduino will check each key press and show a asterisk on the LCD for each digit entered to mask the actual input. Once the password length matches the predefined password length, the entered password is compared to the stored password. If password is correct, the LCD will display access granted. The servo motor rotates to unlock the door. The door remains unlocked for 5 seconds before the servo motor locks it again. If the password is incorrect, the LCD will display access denied for 2 seconds. The user is prompted to try again. Also, we will add a feature to change passwords manually too. When the user press asterisk key, they enter password change mode. The user is prompted to enter a new password. After confirming with hash key, the new password will be saved and the user exits password change mode. It's time to write some code. Download the library and code files using the link given in the description below. Simply click the link to download the necessary files directly. Now, open the code file if you have already downloaded the Arduino IDE, otherwise download the Arduino IDE first. In this code, we'll be using 4 libraries. Keypad.h library to handle a keypad. Wire library to handle I2C communication. Liquid crystal _I2C library to control the LCD display. And servo.h library for managing the servo motor. Let's include the downloaded libraries in Arduino IDE. Go to Sketch. Include library. And then click on Add.zip library. Navigate to the folder location where you saved the downloaded library.zip file. Select the .zip file and click Open. The Arduino IDE will then install the library. Next, we set up our LCD and servo motor. The LCD is initialized with the following parameters. Here, 0 × 27 is the I2C address of the LCD, 16 represents the number of columns, and 2 denotes the number of rows. We also define our servo motor. This instance, my servo, will be used to control the locking mechanism of our door. Now, let's set up our keypad. We define the layout of the keypad using A to D array. Each character represents a button on the keypad, including numbers 0 to 9, letters A to D, and special characters asterisk and hash. We also define the pins connected to the keypad rows and columns. These arrays specify the Arduino pins that are used to read the keypad inputs. Using this information, we create a keypad object. This object keypad is responsible for interpreting the key presses from the keypad. Let's move on to the part where we manage our password variables. Here, password stores the default access code. New password is used during password change. And changing password tracks whether we are in password change mode. In the setup function, we initialize our LCD, servo motor, and display the initial prompt on the LCD. The LCD.begin and LCD.backlight functions initialize and turn on the LCD backlight. MyServo.attach10 attaches the servo motor to pin 10 of the Arduino. Now, let's delve deeper into how our program handles keypad input and manages the door locking mechanism. In the loop function, keypad.getKey function retrieves the currently pressed key from the keypad. We then check if a key press has been detected in ifKey function. Inside this conditional block, we first check if the pressed key is a special key asterisk or hash. If asterisk key is pressed and we are not already in password change mode, that is changing password function, then we switch to password change mode, clear the LCD, and prompt the user to enter a new password. If hash key is pressed while in password change mode, we update the password variable with new password. Exit password change mode. Display a confirmation message on the LCD. And reset it after a brief delay. If the pressed key is a numeric key, from 0 to 9, we append it to new password if we are in password change mode. Otherwise, we call the check password function to verify the entered password against the stored password. Now, let's understand how the check password function works to verify the entered password. The check password function validates the entered password against the stored password. It accumulates each pressed key in input password, displaying an asterisk on the LCD for each digit entered. When input password reaches the length of password, it compares the two strings. If they match, it grants access by displaying access granted on the LCD, unlocking the door using myServo.write 90 function for 5 seconds and then locking it again myServo.write 0 function. If the passwords do not match, it displays access denied for 2 seconds before clearing the LCD and prompts the user to enter the password again. That's all about the code. Now upload the code by following the instructions. Connect the Arduino Uno to your computer using a USB cable. Then select port and board in the same menu and select Arduino Uno. Now upload the code by clicking the upload button. With everything connected and coded, let's see the smart door project in action. Here's our 4x4 keypad ready for you to input the password. The LCD display guides you through each step, ensuring a seamless user experience. Simply enter the correct password using the keypad. As you press each button, the display provides immediate feedback. The servo motor then unlocks the door, allowing you to open it effortlessly. The display shows access granted. After a few seconds, the door automatically locks again. If you want to change the password, simply press the asterisk key to start the process. Enter your new password and press hash to save it. The display will confirm the password change. The system confirms the new password, making it easy to update your security settings as needed. Now, you can install the circuit in any hardware like this and make this project portable by powering the Arduino by using this battery holder with a DC jack. Finally, see the result as we have programmed. You can use solenoid lock and relay to make this project and implement it in your actual door locks. I hope you found this tutorial helpful. Thanks for watching and don't forget to subscribe to our channel for more exciting videos.